Alright, our notes on functions. The first thing we're going to be talking about is the domain in the range. Just a quick review about our domain. We know that the domain is the independent variable. So it's the independent variable. And the domain is all of the x values. And the domain goes from left to right. So when we look at the domain, of our graph, so the domain of the graph, it goes from left to right. Well, the left value, -1, -2, -3, -4, -5, -6. This value is from -6. So it goes from -6, it travels along this graph, -5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 8. So the domain, it goes from left to right. So the domain of our graph, so of the graph, the domain, it goes from -6 all the way up to 8. So x is any number in between -6 and 8. So the domain, anything between -6 and 8. Now, when we look at our table, alright, so now we have our table over here. The domain, we said it's all of the x values. It goes from left to right. Well, the table, all of the x values. So our domain is all of these values. But we don't want to write from 1 to 13 because that's including 2, 3, 5, 6, 8, 9. So the domain of our table is just the x values. So the x values are 1, 4, 7, 10, and 13. So that's our domain of the table. And now we can look at the range. So when we want to look at the range, well, we know that the range is the dependent variable. Alright, and the range is all of the y values. And it goes from bottom to top. So when we look at our graph, well, it's from bottom to top. So, well, the bottom number down here on the range, alright, it's not over here. That's the left number. The bottom number is right here. Well, that number is -1. So the range is going from -1 to the top. Well, the top is up here. So that's 1, 2, 3, 4, 5. So that's 5. So the range, it goes from -1 to 5. So on our graph, this is the graph, the range is from -1 to 5. And in the table, well, once again, the table, it's all of the y values. Well, 2, 3, 4, 3, 2, but we don't have to repeat these. So in our table, we're going to write it in numerical order. So it goes 2, 3, 4, 3, 2. So we're going to say that the range is 2, 3, and 4. So that's for the table. And then if we look at the second part, alright, this is finding some functions. Now, what we can do here is we can fill in this table to help us visualize what's going on. We don't have to, but we can fill in this table. Now, to fill in this table, all we're saying, well, the x values, -1, -2. When x is -3, f of x is -4. That's the point, -3, -4. Then when x is -2, we have the point -2, -2. When x is -1, we have the point 0. So it's -1, 0. When x is 0, f of x is 2. When x is 1, we have 4. When x is 2, we have 2. When x is 1, 2, 3, we have 0. And when x is 4, we have -2. So that's how we filled in this table. Now, when we're looking at the domain, well, the domain, we know that the domain is the x values. And the x values go from left to right. So the x value on the left, it's -1, 2, 3. the x value on the right is 1, 2, 3, 4. So it goes from negative 3 is less than or equal to x, which is less than or equal to 4. Now when you look at the table, it goes from negative 3 to 4. Now it's all the numbers in between because all these points are connected, and this is a continuous function. The range is our y value, so the bottom part is down here, the top part is up here. Well, what's the lowest value? 1, 2, negative 4. The highest value is positive 4. So the range goes from negative 4 all the way up to positive 4. And you can see how the lowest number is negative 4, the highest number is positive 4. Then we get to the increasing and decreasing interval. Well, if we look at this, well, this graph is increasing. It's going up from here to here. So it's going up from here to here. And if we notice that this graph, it's going up from here to here. And then it stops going up. Well, it's going up from negative 3 to 1. Alright, these values are all going up. So it's going up from negative 3 to 1. So from negative 3 to 1, if you notice, this is negative 1, negative 2. So from negative 3 to 1, the x value. So it's increasing. So it's increasing when x is any number in between negative 3 and 1. And then decreasing, well, what happens when it's decreasing is that it's going down. Well, now it's going down from here to here. So it's going down. See how this starts to go down? So it's going down from 1 to 4. So it's going down from here, 1, and it's stopping here at 4. So it's decreasing when x is any number between 1 and 4. It's decreasing. So the graph is going down. If you notice, these numbers are going up, and then they're going down. So that's increasing and decreasing. Increasing, the graph's going up. Decreasing is when it's going down. And then lastly, we have these values over here. It says f of 3. Well, f of 3, 1, 2, 3. When x is 3, the y value is 0. And that's apparent right here. When x is 3, the y value is 0. When x is negative 2, so negative 1, negative 2, the y value is negative 2. And when x is negative 2, the y value, the f of x, is negative 2. Well, f blank equals 4. Well, now the y value is 4. The f of x is 4. So we go up 4. 1, 2, 3, 4. So that's this point. Well, this is the point 1, 4. So that means f of 1 is 4. And that's right here. So we have our f of x value as 4. The y value is 1. And then f blank equals negative 5. Well, our f of x, our y value is negative 5. 1, 2, 3, 4, 5. Alright, there's no value there, so this one does not exist. Okay, this graph isn't continuing, it has endpoints, and if you notice, there's no negative 5 in this entire thing. Alright, so we don't want to put 0, we don't want to leave it blank, we can just say it's not there, it doesn't exist. Comparing our two graphs. So now we have two graphs, and we know that this is the domain, and we can actually just transfer this over from the previous problem because it's the same, the red graph is the same exact graph. So we can just copy this entire thing down. So we have negative 4, negative 2, 0, 2, 4, 2, 0, negative 2. So negative 2, negative 4, negative 2, 0, 2, 4, 2, 0, negative 2. Alright, so we have the f of x. We already did it. Now if we look at g of x, when it's negative 3, 1, 2, negative 3, 1, 2, 3. We have positive 3. When it's negative 2, we have positive 2. When x is negative 1, we have positive 1. It's a little below that line. When x is 0, it's about halfway in between. So that's about 0.5. When x is 1, that's negative 2. When x is 1, 2, that's negative 1. When x is 1, 2, 3, that's 0. And when x is 1, 2, 3, 4, we have positive 1. So that's how we're getting these values. Now, if we take a look at this, it says f of 2 plus g of negative 1. Well, f of 2. So we look at our red graph, our graph of f of x, and 2, so 1, 2. That is the value of 2. And g of negative 1, well, negative 1, we said it's a little less than 1, but we will call it 1. So 2 plus 1 is 3. And if you look at the table, when x is 2, f of x is 2. And when x is negative 1, g of x is 1. So that's how we got 2 plus 1 also. And now if we look at b, g of 4. Well, g of 4, well, we look at our g of x graph in 4, 1, 2, 3, 4. Well, that's the point 4, 1, so this is going to be 1. F of 1, well, when x is 1, that's 1, 2, 3, 4. So 1 minus 4 gives us negative 3. So g of 4 minus f of 1 is negative 3. You can look at your graph. When x is 4, g is 1. When f is 1, you get 4. So 1 minus 4 is negative 3. What value is greater, f of negative 2 or g of negative 2? Well, when we go and look at our graph, f of negative 2, negative 1, negative 2, f is here. So that's on the f of x line, so that's negative 2. So this value is negative 2, and compared to g of negative 2, this value is positive 2. Well, what's bigger, negative 2 or positive 2? 2 is bigger. So g of negative 2 is greater than f of negative 2. And if you look at this, we look at negative 2, and we can compare that. 2 is greater than negative 2. And then it says, well, when is f of x equal to g of x? Well, for them to be equal, they have to be the same. Well, where do they intersect? Where do they cross? Well, they cross right here. They also cross right here. So they have two intersecting points. Well, we're looking for the x value, so x value is negative 1. And, well, this one here, we actually said that this one's not really, the g of x is a little off center there, so that's why that's going to give us a little wrong answer. But 1, 2, 3, they intersect here where they're both 0. So when they're both 0, x is equal to 3. Now with the other one, my graph isn't all that great. It was supposed to be at negative 1, but these values aren't the same here, and it's because we have a 0.5. So they do intersect, but we're not exactly sure what this value is. Later on in this unit, we will be able to determine that value exactly where it is that they intersect. So we know that one of those is 3 because they're both 0. So we will find the other value later on in this unit. And it says, when is g of x greater than f of x? Well, when is g bigger than the f? Well, if we compare these, well, g is bigger, g is bigger, g is bigger, g is bigger, but then now g is smaller, 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 but once again g is bigger, so it's greater here, and it's also greater here. So it's greater from this value. Let me just change this color. So it's greater from this value until here. So it's greater from negative 1, 2, from negative 3, negative 2, negative 1. So it's greater from from -3 to -1. And then it's also greater when